trigonometry. All right, so here it is, the good old right-angled triangle. There we go. And when I said we're going to start from the very basics, I mean the very basics. That's the hypotenuse. Now, the other two sides, which of course we call adjacent and opposite, we can't really name them until we know which angle we're referring to. So I'm referring to the one at the top. Traditionally, we use Greek letters for the angles. Don't know where that comes from. Probably from Greek. I don't know. But there we go, adjacent and opposite. When it comes to the naming of vertices, again, traditionally with triangles, capital letters for the vertices, the lowercase letters for the sides. Ta-da! Now, of course, we say sin, cos, and tan, but they're actually sine, cosine, and tangent. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All sorts of wonderful and creative ways people come up with remembering SOHCAHTOA. Some old hags can't always hide their old age. You know, all those sorts of things. Mind you, that second one's probably not politically correct anymore. I don't know. There are, of course, the reciprocal ratios, which we don't spend a lot of time with, but they become extremely important in the work we're going to do in the senior years anyway. So there's cosec, which really is cosecant, sec, which is, and cot, which is cotangent. And they're called the reciprocal ratios because they are the other ones turned upside down. And I always think it's strange, they try to confuse us, that the reciprocal of sine is cosec, and the reciprocal of cosine is just the sec. I mean, who came up with that idea? Wouldn't it have made life so much easier if they did it the other way? But they didn't. So it is what it is. Sine of x equals the cos of 25. What's x? Okay. Again comes down to the definition of the word. Why is cosine called cosine? Complement. Right? They are complementary ratios. Therefore, the angles add up to 90 degrees. So the sine of x is the cosine of 25. X must be 65. They add up to be 90. So 90 minus 25, 65. And that's the same with secant and cosecant. And that's the same with tangent and cotangent. The co means they are complementary ratios. So if I get something like that, cot of x minus 20 is the tan of x plus 30. Again, I just say, oh, well, I know the two angles, they've got to add up to be 90. So I just solved that equation. There we go, x equals 40. That's assuming, of course, all the angles are acute. Once we start getting into obtuse angles and that, it's a little bit more involved. But assuming the angles are acute, then we can do that. Then we got into, all right, let's find the sides. And we'd say, okay, let's set up the ratio. The ratio I've got here is opposite over adjacent. So I know it's tan. Then, like any equation, get rid of the fraction, multiply by 13, punch it into our calculator, and I've done mine to one decimal place. There's our answer. Of course, there are other ones where it's the hypotenuse we're trying to find. So when we set up our ratio, the pronumeral ends up on the bottom. So x is 5 divided by... Simply, it is if the pronumeral is on the top, then I'll multiply. If the pronumeral is on the bottom, I'll divide by the trig. That's how it turns out. So in this case, it's 5 divided by sine 32. Of course, I could have wrote it as x over 5 is the cosecant of 32, thus the pronumeral being on the top. But really, there's only one reason I don't do that. Why? Yeah, I don't have a cosecant button. So we tend to put things in terms of the three ratios that we do have. And 9.4. And of course, the third type of question is where we have to find the angle. So cosine theta is 10 over 4. Theta is what we call the inverse cos. Right? It is the inverse function. Remember we talked about inverse functions? If you want to go back the other way, you have to do the inverse. So with trig, they're simply called the inverse trig functions. You may have noticed them on your calculator, you may not, but they're simply on the same button usually, but you have to press shift or second function or whatever it happens to be on your calculator to get the angle. The only thing to be careful with, and it's not that big a deal right now, but it will become a bigger deal later on, is we have to make sure our calculator is set to degrees. There is, of course, radian measure that we will end up using a lot more later, which makes sure it's in. Because the calculator needs to know, okay, you're inputting this angle, but what units are you using? So you just make sure the calculator matches whatever units you happen to be using. The exact ratios. We should know them by heart. But if you ever forget, just remember how they're created. Triangle. It's an isosceles triangle. Okay? But I chop it in half. So when I chop it in half, I get my 30-60 triangle. Hence, one side is 1, one side is 2. And by good old Pythagoras, we get the square root of 3. And from that, we can read off our exact ratios. There we are. Sine 30 is a half, cos 30 root 3 on 2, tan 30 1 on root 3, and then the 60. But by the way, 60 and 30 add up to be. Thus, the complementary ratios are equal. Sine 30, cos 60. Sine 60, cos 30. Tan, they're not complementary, so they don't. All right. 45, again, we start with an isosceles triangle, but it's like, and if you ever think, well, where do these triangles, think of your set squares. It's basically your two set squares, your 30-60 triangle and your 45 triangle. We make the sides 1 to make life easy. Hypotenuse is root 2, and there we go. Sine 45 is 1 on root 2. So is cos 45, because 45 and 45 equal 90, that's right, very good. And tan 45 is just 1. There is another way of remembering them. I don't know whether you've seen this or not. But the boundary, if I include the boundary values of 0 and 90, sine, there you go, square root of 0 on 2, square root of 1 on 2, square root of 2 on 2, square root of 3 on 2, square root of 4 on 2. So she goes 1, 2, 3, 4. And then cosine, because they're complementary, must read the same but backwards. Okay? And tan is sine divided by cos. So I forget about the denominators, and there's my tans. Root 0 over root 4, root 1 over root 3, root 2 over root 2, and so on. So there's a different way, I guess, of remembering the exact ratios. Measuring angles. Measuring angles. Angles of elevation. Elevate means to lift. And so that would be an angle of elevation. How do we say it? The language of it is, it's the of B from A. So it's of what you're looking at from where you are. So that'd be angle of elevation of B from A. Depression is to drop. So a similar sort of thing. There you go. And that would be of X from Y. Of X from Y. And in any picture, the angle of elevation will equal the angle of depression, because of course you're talking about alternate angles. Compass bearings. All right. But then we sometimes divide them exactly in half, and we go with the north and south first. So northeast, southeast, southwest, northwest. And of course, we could divide those again. Again, we start with the north first. So north, northeast. The second one, east is more important than northeast, so we go east, northeast, and then it's east, southeast, and south, southeast, and south. Theoretically, I could keep going. I could divide again, so halfway between, or let's pick one. Let's say halfway between southwest and west-southwest would be, well, the more important, or the higher up in the hierarchy would be southwest, so we start with southwest. So halfway between would be southwest, west, southwest. And you could divide by again and again and again. It starts getting a bit confusing after a while. So we tend to, after that, just say, all right, north, and I'm going this many degrees towards east, or this many degrees between. True bearings is another one, where we just start at north and say, okay, I'm going around this many degrees. So there's X, there's Y. the bearing of y from x. So the compass is at x. Let's put it in. That's 30 degrees. So it's 120 degrees as a true bearing. Start at north, go round. As a compass bearing, I could say, oh, well, it's south and I've gone 60 degrees towards the east. And if it was of x from y, well, now the compass is at y. Bit of geometry, we can work out that's 60. So 300 degrees is the true bearing. North, 60 west. Yeah. How nice. Well, 1 to 3, just pick some to do. Just pick some.